Hi everyone. So today I thought I would go through some of the questions from the 2018 JEE Advanced exam that I really struggled with. So I'm going to start with question 4. This is from paper 1. I'll be going over a question from paper 2 as well, because I've finished both of them now. So pause the video here and see if you can figure this one out. And it's part D that's the hard bit, by the way. Oh, and I forgot to mention that this isn't like a standard multiple choice where only one of the responses is the correct one. It's like we have to decide for each one whether it's true or false. Alright, I'll just run through parts A, B, and C quickly before I get on to D. So part A, what that's talking about, I would think of one-to-one for a real function. That means like it's going to pass the horizontal line test. So it's going to be doing something like that or that, and not being like this, where if you run a horizontal line through, it cuts multiple times. And we just want that to be true on an interval. So, I mean, that would actually be fine because we can just restrict it to some little interval where it is one-to-one. Okay, so intuitively, if it's twice differentiable, then it's quite a smooth function. It's not jumping around and its derivative isn't jumping around. So intuitively, like right off the bat, I thought, yeah, definitely true. Although it's not really that simple, because just from that fact, it could still be something like f of x equals 0, which is one-to-one nowhere. So if we only had that amount of information, then you'd have to go, that's false. But if we use this fact, then that lets us conclude that f prime of 0 can't be equal to 0, since f of 0 has to be between -2 and 2. So that means that it's not going to be something like that. And yeah, so it's definitely going to be one where we can cut it into some sort of interval where it is one-to-one on that interval. So that one is true. Okay, part B. So I was kind of thinking of this as saying, would it be possible for the slope to be bigger than 1 or less than -1 for that entire interval, -4 to 0? And then I think it's quite obvious that that is not possible. Therefore, there has to be an x-naught such that that is true. Because if the slope was greater than 1 for that whole interval, then you know, it has to stay between -2 and 2, and that wouldn't be possible if the slope was bigger than 1 for that whole interval. So intuitively, I think it's kind of obvious that that's true. But if you want to know sort of the more rigorous, less hand-wavy way of proving that, you can use the mean value theorem. So we can say that there has to be an x-naught in that interval such that f prime of x-naught equals f of 0 minus f of -4 over 0 minus -4. That's the mean value theorem. And then that's f of 0 minus f of -4 over 4. And then if we want to know something about the absolute value of that, let's just chuck absolute values around here. So that's that. And then because f has to lie between -2 and 2, that's going to be at most 4. So we can say that's less than or equal to 4 on 4, which is 1. So f prime of x-naught will be less than or equal to 1 for some x-naught in that interval. Okay, part C. So you can work this one out just by thinking of an f of x that satisfies those conditions but breaks this. So we could have something like, sort of like a sine function doing whatever, and then you can just sort of scale it so that that will be true. I mean, this one that I drew isn't so good, because we want a big slope at the origin. Let's just stick the origin there. So I can kind of like squish that function until f prime of 0 is big enough that that's true. And then you can see that that limit doesn't exist for this choice of function. So that one's going to be false. Okay, part D. So this is where I got stuck. I really did not know what to do. So the sort of line of thinking that could have led me to work it out would have been something like, we haven't really used this fact enough yet, so we're probably going to need that for this. And we've got this second derivative here, so kind of a good thing to do would be maybe differentiate this somehow so that we're going to get a second derivative. But obviously not differentiate this, because this is a constant, like f of 0 is just some number. So maybe we define g of x like that, and then if we differentiate g of x, that's going to give us some sort of expression that's going to involve f second derivative. So hopefully that'll help. So we define g like that. We know that g of 0 is 85. And let's just differentiate g and see what happens. So g prime of x equals, so applying the chain rule there, you're going to get 2 f of x times f prime of x plus 2 f prime of, oops, that's meant to be an x there. 2 f prime of x times f second of x. Okay, what can we do with that? Well, we've got this 2 and f prime common factors, so maybe we can factorize that. Okay, so now what we're trying to prove is that there's an alpha in there such that that is equal to 0. So maybe what we're trying to do is prove that there's an alpha such that g prime of alpha equals 0. And maybe we could get there by applying the mean value theorem. So that's the kind of line of thinking that would lead you to being able to solve this. So what we want with the mean value theorem is, well, we want g prime of alpha equals 0, right? Because that's going to lead us to say, okay, either this equals 0 or this equals 0. So what we want is for us to find an a and a b, so that this is going to be 0. So g of b has to equal g of a. Basically, that's what we're looking for. So let's think about that. Let's just draw g. So we know that g of 0 is 85. And then, so we're going from -4 to 4. Now, those sound familiar because we had a -4 here. Okay, so maybe we can use that fact. We've proved that this is true. So there's an x naught in -4, 0 such that absolute value of f prime of x naught less than or equal to 1. So let's think about what that's going to mean for g. So we're saying that that is less than or equal to 1. And we know that f of x is between -2 and 2. So that's like up to 4 when we're squaring it, and that's up to 1. So we know that there's going to be some x naught where g is at most 5. Because we proved that there's an x naught such that f prime of x naught is less than or equal to 1, and we know that that is less than or equal to 4. So there's some x naught where, this is the graph of g, where g of x naught is going to be below 5. We don't know where exactly, it could be sort of anywhere below 5. And then we can kind of do the exact same argument as this works for x naught in 0 to 4. So we know that there's another value of x, let's call it x1, where that's also going to be true over here. So there's going to be another x1 over here, such that g of x1 is less than or equal to 5. Okay, how does that help us? Well, remember what we're trying to do is find an alpha such that g prime of alpha equals 0, which we're going to do by using the mean value of the mean value theorem, where we want to find some a and b such that g of b equals g of a, because that's going to make that 0. So we actually know that g of x is going to be continuous because f was twice differentiable. So if it's twice differentiable, that means that the derivative has to be continuous, and f has to be continuous. So we know that that's continuous and that's continuous. So g is continuous, meaning that if g has to get from there to there, it's got to pass through that line somewhere. And same thing over here. So we actually know that there's some a and b such that g of a equals 5 and g of b equals 5. So that is very helpful, because now we can say there's going to be some alpha somewhere, inside this range from a to b, such that g prime of alpha is equal to g of b minus g of a on whatever b minus a is. And so we know that a and b exist such that the g of a and g of b are both 5. So that's going to make that 0, like 5 minus 5 up here. It doesn't matter what a and b are, we just know that they have to exist because g is continuous. Okay, so we know that there's some alpha in here such that g prime of alpha equals 0. And that tells us that this equals 0. Now, there was this bit here where we have to be able to show that f prime of alpha is not equal to 0. So, yeah. So we know that, let me just rewrite this. So g prime of alpha is that. We know that that's 0. Let me just get rid of the 2 as well. We can divide both sides by 2. So we know that f prime of alpha times f of alpha plus f second of alpha equals 0. So we have to be able to work out that f prime of alpha is not 0 to be able to conclude that this is 0, which is what we're trying to show. So how are we going to do that? Here's where I actually forget what I did. Now, so we know that, let me just gather my thoughts here. Okay, because alpha is between a and b, and we know that g of x is bigger than 5 between a and b, because that's how we define a and b. Well, we know that because we can pick a and b to be like the first time it crosses that line. So we can say that g of alpha is greater than 5. Now, because g is that, and we know that that is at most 4, because f is between -2 and 2, that means that this has to be at least 1. So f prime of alpha can't be equal to 0. So that means that that has to equal 0. So that has proved that, so that is true. And that whole thing was very confusing. That is actually quite a hard question. But I hope that explanation made sense to you, and it made sense how you would come up with that line of thinking. Okay, question 5. So pause the video here, see if you can figure this one out. Okay, so in all honesty, I got completely stuck on this one. I had no idea what to do, and I had to look up the solutions. So anyway, with equations like this, often what you want to do is move, like all the y's over one side and all the x's over the other side, if you can. So what you want to do with this is try to move all the f's over one side and all the g's over the other side. So let's think about how to do that. So what we want to do is like separate these. So we could say that's e to the f of x times e to the minus g of x. And then we want to shift this over that side. So divide by it, which is going to turn it into e to the minus f of x. Okay. So from there, what we need to do is think about kind of integrating both sides. So you can kind of recognize that that is the derivative of negative e to the minus f of x, because by the chain rule you would get that. And then over on the right we've got derivative of negative e to the minus g of x. Okay, so that's really cool. Let's just cancel the negatives. Just get rid of those, like multiply both sides by -1. Okay, and then we can say, since their derivatives are equal, then they are going to be the same, except maybe with a constant difference. So we've got that. Now let's see if we can use this fact. So knowing that f of 1 is 1, let's plug in x equals 1. So we've got e to the minus f of 1, which is 1, equals e to the minus g of 1 plus a constant. Okay, now let's try plugging in x equals 2 into here. So we've got e to the minus f of 2 equals e to the minus g of 2, which is 1, plus a constant. So let's subtract these two equations so that we can get rid of the c's. So let's call that equation 1, equation 2. I'll do equation 1 minus equation 2. So on the left we'll get e to the minus 1 minus e to the minus f of 2. And on the right we've got that e to the minus g of 1 minus e to the minus 1, that one. And the c's cancel. Alright, so let's see what we can do with that. So we're trying to prove something about g of 1 and f of 2, some inequality about that. So what I might do is like move that over the left, so we just have the g of 1 by itself on this side. So add e to the minus 1 to both sides, so we get 2e to the minus 1 over here. So e to the minus f of 2. Now we don't know anything about f of 2 at this point, but we do know that this is going to be positive because e to the whatever is always positive. So we could say, and then we're subtracting a positive, so we could say that e to the minus g of 1 is going to be less than 2e to the minus 1 because we're subtracting some positive number from that. And then that's starting to look good because we've got like this log 2 in there and stuff. So if we take ln of both sides of this, that's going to give us ln 2 minus 1. Log of that is minus 1. And then on the left you'll have minus g of 1. And we can say less than because log is monotonic. Hopefully that's a word that you understand, otherwise look it up on Wikipedia, because it's monotonic increasing. So we don't have to like flip the sign of that or anything. Okay, and then we can multiply both sides by -1, and that will flip that sign. And we'll get 1 minus ln 2. Okay, so g of 1 greater than 1 minus ln 2, that's C, so that one's true. That one's false. Let's see if we can do the same thing with f of 2. So going back to here, let's just rearrange that a bit. We can say e to the minus f of 2 equals 2e to the minus 1 minus e to the minus g of 1. And then since that's positive, we're going to have something that's less than 2e to the minus 1. And in fact, this is going to be like all the same as what I've done here. So at the end, we're just going to end up with the same conclusion that f of 2 is greater than 1 minus ln 2. So that is B. That one's true. That one's false. Okay, so that was question 5. All right, question 6 was the next one that I got stuck on. I don't know why it was 4, 5, and 6 that I couldn't do. All the rest were fine. But anyway, so pause the video here, see if you can figure this one out. Okay, so for this one, I had an idea that what we needed to do was differentiate both sides of this equation so that we could get some sort of differential equation so that we can find f. But I could not work out how to differentiate this convolution because it's got like an x up here and an x in here. Like, how do you even deal with that? So I eventually found the Leibniz integral rule, which is what we need to use to differentiate that, because that's the kind of thing that we have. So we just need to apply this formula. Okay, so let's just start with the easy bits. So differentiating both sides of this. On the left we've got f prime of x. Derivative of this is just -2. And then we've got the derivative of this thing. So the first bit is, so you plug in the b of x as t. Plug in t equals b of x. So this with that instead of t. So we've got e to the x minus x, f of x, and then that multiplied by the derivative of what's up there, which is just 1 times 1. Okay, and then we've got this bit. Now, d by dx, a of x, so that's a of x. For our function here, that's 0, so the derivative of that is going to be 0. So we can just sort of ignore that bit. That whole thing is just 0. And then we've got this. So integral 0 to x, and then we need the partial derivative of this with respect to x. So because it's an exponential, that actually doesn't change it, and it just stays as e to the x minus t, f of t dt. Okay, so then what we can do, let me just clean this up a bit. So we've got -2, that's 1, because we've got e to the 0, and then times f of x times 1, so just f of x. Now this, we can go back to the original statement and just solve it for this and plug it in there. So this, let's just shift that stuff over the other side. That's going to equal f of x plus 2 of x minus 1. So put that in there, plus 2x minus 1. And then let's just simplify this a bit. 2f of x plus 2x minus 3. Now, the way that I solve this is different from how I saw other people doing the solutions. Let me just go through my method first, because I think it was a lot easier. So, my method, I've forgotten what it's actually called. It's like the method of undetermined coefficients or something. But basically what it is you just sort of guess at what f of x might be, and then plug your guess into this formula and see what happens. That's basically it. So you sort of get an idea of what to do from doing simpler ones. So you'd probably start out by equations like f prime of x equals 2f of x. Something like that is quite simple to solve. That would just be f of x equals a e to the 2x. So some constant that we don't know times e to the 2x, because we know that when we differentiate that, it's going to give us 2a e to the 2x, which is 2f of x. So that satisfies that condition. Now, I was just, guessing if we've got some sort of linear function out here, then what we want is f of x being, so basically the same as this one, but just with some linear thing tacked on the end. So see if that works. Okay, so what we can do, clear some space there. So we just want to plug this guess into this formula. So f prime of x equals that. And then that'll let us hopefully determine what these numbers a and b are, and maybe that one. So we need the derivative of that on the left. So derivative of that is, no, wait, why do I have that 2 there? I don't know. Derivative of that is 2a e to the 2x, and then derivative of this is just a. So that's the left-hand side there, and then on the right, we've got 2 times our f of x, and then plus 2x minus 3, and then let's just expand this, 2a e to the 2x, plus, now we've got 2ax and a 2x. I'm just going to collect those together. And then we've got 2b minus 3, and that's equal to this. And then these just cancel. Okay, so now we've got to work out what a and b are from this. So if this equals that, like there's no x on this side, that means that 2a plus 2 has to be 0. So that gives us a equals -1, and then let's plug that back into here. So on the left you've got -1, that bit is 0, we've got 2b minus 3, and then we can solve that for b. b has to equal 1 from that. So you just, the idea is you take a guess of what the function looks like, you plug it back in, and then you work out what these constants have to be in order to satisfy the differential equation. Okay, so we've got a equals -1 and b equals 1. So far what we have is that f of x is a e to the 2x minus x plus 1, just plugging these values into there. And now what we have to do is try to figure out what big A might be. So what we would like is, usually with differential equations you get an initial condition. So you'll know what f of 0 is, for instance, or f prime of 0 or something like that. So we're going to have to work out what f of 0 might be from this. So 0 is a good value to pick because if that's 0, then this is really easy because we know that's going to be 0 because it's the integral from 0 to 0, so that has to be 0. So we know that f of 0 has to equal 1 just by plugging x equals 0 into there, because that's 0, that's 0. F of 0 is just 1. So that will let us work out what A is, because now we can say 1 equals, so I'll just plug 0 into here. So A e to the 0 minus 0 plus 1. That's just 1, so let's get rid of that. Let's just get rid of that. So 1 equals A plus 1. So A has to equal 0. Now here's where I got stuck again, because I thought that I must have made a mistake here. I don't know why I thought that, because you can actually check that this works. So now if that's 0, we've got f of x equals 1 minus x. You can actually plug that into there and make sure that it satisfies that condition, and it does work. So I don't know why I thought that I'd made a mistake, because it's just been so long since I've done differential equations. Anyway, so that is f of x. So now we can start answering these questions. So does f of x pass through the point 1, 2? So if x is 1, then we get 1 minus 1, which is 0, so no, it's not 2. If x is 2, then we get 1 minus 2, which is -1, so that one works. That one is true. Now let's think about what this is asking. So yeah, this might be a bit confusing for some people, like what is that actually saying? Let me just start by graphing y equals root 1 minus x squared. It really helps to graph these things to try to work out what's going on. And this is saying that x is between 0 and 1, and just y is a real number. So this is actually, that would be a semicircle, like that. And if we're interested in x from 0 to 1, I'm just going to draw that much of it, so a quarter circle. So x running from 0 to 1. And we want f of x to be between, no, we want y to be between f of x and that, the one that I've just drawn. Let me graph f of x as well. So y equals 1 minus x is going to look like that. Now, the area of that region where y lies between f of x and root 1 minus x squared, that is talking about this. This is where y lies between there and there. So it's asking for the area of that. Now, if this was any other function, I'd probably do an integral. I'd do like integral from 0 to 1 of this minus that and work that out. But because it's a nice circle thing, we can just use basic geometry to work this out, to work out that area. So the area of like this whole quarter circle, that's going to be like pi r squared over 4 with r equals 1, so it's just pi over 4. And then we can subtract off this triangle in here. So half base times height, the height is 1, the base is 1, it's just half. And then that makes pi minus 2 over 4. So that one is true and that one is false. So that's how you do question 6. Okay, let me just back up here and show you the other method for solving that differential equation. So that was, we got to that point after we differentiated both sides of that. Now the method that I used is called the method of undetermined coefficients. The method that I've seen other people using for this exam is this stuff, which I guess is called non-separable, non-homogeneous first-order linear ordinary differential equations. This is just on the Wikipedia page for examples of differential equations. So the idea is, well, first I'm going to rearrange it into that form. Okay, so now it's in that form. This -2 is the p of x over there. So now we have to choose a special integrating factor, mu, which you get by integrating p of x. So if p of x is -2, integral of that is -2x. So we choose mu equals e to the -2x. So that's what I've done there. And then what we do is we multiply both sides of this by mu to get to here, which is what I've done there. Okay, and then what you do is you recognize that this is the product rule applied to this. So this is the derivative of this. So from there what you want to do is integrate both sides. So we get to here. And then to integrate this, so let's just separate it off into, you know, like expand that and separate it. So we have to use integration by parts to do this. So we do integration by parts, and it's a whole big annoying messy thing, and we eventually get down to here, and then we want to move that over the other side. So multiply both sides by e to the 2x, and that gets us to there, which was the same thing as what I got, just with, I used a lot fewer steps. I feel like the undetermined coefficients method was way easier than all of this. But I'm glad that I saw other people doing this, because I did actually need to use this method for paper 2. Yeah, so it is obviously something that you need to know for the JEE. Okay, so the next one I ran into trouble with was question 7 on paper 2. I think paper 2 is meant to be harder than paper 1, but I actually found it easier just because there were a few things that I didn't know when I went into paper 1 that I had to learn. So by the time I got to paper 2, I was actually, you know, up to speed with everything. So this was the only one that I really struggled with. Anyway, pause the video here, see if you can figure it out. Okay, so when I did this one, I used the substitution u equals 1 minus x, and it was really messy. I had to use integration by parts and then do a couple other leaps of mathematics, so it wasn't so good. So I looked at some other YouTubers and how they did it, and there was quite a clever way of doing it, which works out really neatly. Now, if I was to come across this integral in real life, I'd just like plug it into Mathematica or whatever. You really don't need to be able to do weird integrals like this, but apparently you do need to do them for the JEE. Okay, so let's just simplify it down to that a bit. Now, the idea with this is that what we want to have is, like, we want to sort of bring part of this inside here. We want to have like 1 minus x over 1 plus x to the 3 on 2. And then what's left over, if we do that, is to have x plus 1 squared. So that's the same as this, because if you sort of simplify this, you get x plus 1 to the 2 divided by x plus 1 to the 3 on 2, and that would give you root x plus 1. Now, this is really cool, because now what we can do is say let u equal this. And let's work out du. So differentiate this using the quotient rule. Derivative of that is -1, so negative 1 plus x, minus derivative of that is just 1. on 1 plus x squared. And then this just simplifies down to -2. So that's really handy because this is what we have here. So let me actually just rearrange this a bit. du on -2 equals dx on 1 plus x squared. So we can take that and that, get rid of them, replace them with this. So that's going to simplify things so much. 1 plus root 3 over, so we've still got this, u to the 3 on 2, and then these, replace them with this. And then these, when x is 0, u is going to be 1 minus 0 over 1 plus 0, so just 1. And when x is a half, you're going to get a half up here and 3 on 2 there, so that'll make 1 over 3. Now, what I might do with this is just take that negative out and use it to flip these around. Hopefully that makes some sense to you. If you flip these around in an integral, then you get the negative of what you had, and so that'll cancel with that negative. So I'm just going to put these around the other way. So that's just a bit simpler to deal with. Okay, so we just want to integrate that. Let's pull the 1 plus root 3 out the front, and then this will be u to the -3 on 2. Oh, and let's pull that out as well. Okay, so when we integrate that, we get u to the -1/2, and then I have to divide by -1/2. And then that's quite handy because it'll cancel with that too. So like that cancels with that. And then we're going to get 1 plus root 3. So plug in the 1, that just makes 1, and then we've got the negative as well. And then we're supposed to subtract that when that's plugged in, the negative's going to cancel and make that positive. So if we plug in a third to there, so it's like 1 over square root of a third, which makes just root 3. Okay, and then this is difference of two squares, like we've got root 3 plus 1 times root 3 minus 1. So that's going to make 3 minus 1, which is just 2. So that's how you do that one. I did not come up with that by myself. As I said, the way that I did it did work, but it was messier and dumb. Okay, so those were the questions that I struggled with from the 2018 JEE Advanced. Let me know if there's any questions that I haven't covered that you found difficult. And don't forget to like and subscribe, and I'll see you in the next video.